Okay, you guys, my sister FaceTimed and it cut off my video, so I apologize. I guess it kind of works out. So those of you who may not have actually paused the video, you definitely had to pause. But anyways, we'll keep going. So here's number one. Here's where I left off of the 4 that I asked you to try. So we're going to do 6 pi divided by 4, and that simplifies to 3 pi over 2. Okay, then we're going to do 6 pi over 2, which reduces to 3 pi. And then we're going to take the first one, 3 pi over 2, and times it by 3, which will give me 9 pi over 2. Okay, so then I'm going to try to set my asymptote. So in order to set the asymptotes, I just think it's the reciprocal of sine. Sine starts here at the origin, but we've talked about how now, you know, if we reciprocate 0, it's undefined. So we don't want to actually start it there. That just means that's where our asymptote goes. And then with cosecant, we do every other. Okay. And then we can put our points in. So sine goes up on the right, and so does this one, because it's not a reflection or anything. So it's going to go up on the right, down on the left, and then the opposite. Okay. All right, I think I got everything on that one, so let's go to the next one. So the next one is cotangent. So our amplitude is none, but our quote-unquote amplitude is 4, which is a vertical stretch because A is greater than 1. Our period, okay, so this is where we have to be careful because I almost did this, you know, incorrectly. So we got to really think. It's pi over b instead of 2 pi over b because this is cotangent, all right? So then it's pi over 1/2. Remember, here's your imaginary 1. So there's your 1/2, and that's 2 pi. Now that's good news because that's what we're kind of used to. So labeling those should be a breeze. I think most of us kind of have them memorized. All right, so let's get the asymptotes set. So cotangent's the one I like the best because the asymptotes are on the ends, perfectly on the ends, and then perfectly in the middle. And then cotangent is a decreasing graph, and there's no reflection here, so it's going to stay decreasing. Okay, so here, down, down, decreasing. Oops, I missed it. Let's try that again. That was pretty bad. Take my time. All right. Okay, let's keep on keeping on. So with the next one, our amp is 1, which is no change. Our period, okay, so this is secant. So we're going back to the 2 pi over b. So we're going to do 2 pi over 3. Okay, so we might want to do a little math to get the, so we're going to divide by 4, which is like timesing by 1/4. All right, so that'll be 2 pi over 12, which simplifies to pi over 6. Okay, then the next one we're going to do 2 pi over 3 divided by 2, which is like timesing by 1/2. So that equals 2 pi over 6, and that reduces to pi over 3. And then we're going to times, I'm running out of room, sorry. We're going to times pi over 6 by 3. So that'll be 3 pi over 6, and that reduces to pi over 2. We've done that one a time or two, but that one is definitely a hard one if you're doing it by hand, those of you who don't have a Casio calculator. So just be careful. Now notice, let's make a note here, this has a reflection. So we want to be real careful about that. All right, let's get our asymptotes set. So secant is the reciprocal of a cosine. Cosine starts up at the amplitude typically, but this is a reflection. So instead of starting up, it's going to start down. Is everybody okay with that? And so then I can set my asymptotes to every other one. Okay, and so now I'm going to make these black So anything that was up is now going to be down, and anything that was down is now going to be up because of the reflection. So this one is going to start down, and it's going to go up on both sides. Anything that's a point that is at the top, the parabola should be pointing up, even if it's a reflection, okay? And so again, if you remember, we talked about how with secant, we should, if it's a reflection, it's kind of like cosine, so it should make a M. Don't do this, but if you can see my highlighter here, you can see it does make an M. So that helps you know that you're on the right track, okay? All right, and then lastly, let's go look at this one. So tangent, I'm sorry, I'm going to have to go like this so you keep it straight. So tangent, our amp is none, but our quote-unquote amp is 2, which is a vertical stretch. Our period is, so be careful on this one. Our period is pi over b, and our b is an imaginary 1 here, so it's just pi. So that's no change from our original, but we do have a reflection, so let's be careful about that. Okay. All right, so let's set our asymptote. Well, actually, let me mark the tick marks first. So pi over 4, pi over 2, and 3 pi over 4. Okay. And now let's do our asymptote. So tangent, if you remember, it's 2 to the right and then 2 to the left. All right, and then tangent is typically an increasing graph, but because of the reflection, it's going to be a decreasing graph. So we're going to start at the top, middle, and then go to the downward side, and so that should be a decreasing graph. And then we're just going to do it again. Remember, the third point is not visible, but we kind of know where it's going to be. And then you have to kind of think backwards here. Oops, see, I just messed that up. We got to be careful. I need to be careful. So the end is going to be down at the bottom. We don't know where this, I mean, we do know the top point is up here. We just don't have it. Okay. So, again, you do not have to submit anything to me today. I just want to make sure that you really, thoroughly understand these 4 examples, because I kind of mixed them together. Started with cosecant, then went to cotangent, secant, and then tangent. So those are the 4 that we've learned since this virtual learning began. So if you can do those 4 pretty well, I'd say you're on the right track. Now all we need to do is try to kind of pull everything back together, even with sine and cosine. So we'll try to be doing that in the next couple of days. But I'll talk to you later. Have a good one.